Hello students, welcome back to Education on Cloud. So here we are with another chapter, that is applications of trigonometry. So we have completed introduction to trigonometry and this is the continuation. You can call it as a continuation which is application to trigonometry. Right. So before we start with the questions, first let's understand few basic topics which are related to the questions. What is line of sight and what is horizontal line? So we are aware of what is going to be your horizontal line. I would just like to give you an example. So horizontal line is something like this and vertical line which is going to be like this, right? So this is nothing but horizontal line. So the explanation says the line which goes parallel from eye to ground is called horizontal line. So if you just consider this to be your ground, so which is parallel, it is going to be your horizontal line. So we have understood that this is going to be your horizontal line. So what do you call as line of sight? So suppose, let me consider that person A, Mr. A, so Mr. A is standing over here, right? If Mr. A is standing over here and his is just flying a kite, so let me just consider this to be the kite, right? So when he is just flying the kite, he is just going to see there, right? So what does that mean? So he is just looking at there. So this line of sight, this is called as line of sight. Line of sight. Why? Because he is standing over here, but he is seeing the kite which is just flying in the sky. So this is line of sight which is standing from here and he is seeing there. So what does the statement tell? A line of sight is a line drawn from eye of an observer. So he is standing over here. So eye of an observer to the point where the object is viewed at the observer. So it is going to be over here, right? And it is not necessary he is flying a kite. Suppose he is standing on a building, right? He just wants to see a ball which is over here, right? If we just have to see a ball which is over here, so the line of sight can be like this also, right? Even this is also going to be the line of sight. Next thing, angle of elevation. So even over here also we can just continue the same diagram which we had considered. So as I said you, Mr. A was just standing over here and he was just flying a kite, right? So this was Mr. A who was just standing over here and we had a kite over here, right? Now what does this say? So this was my line of sight and this is my horizontal line. So when this is a given case, so what does that mean? Angle of elevation is an object viewed is the angle formed by the line of sight with the horizontal line. So we have line of sight as well, horizontal line also. So it is nothing but whatever angle it is formed in between, it is called as angle of elevation. So this angle is said to be called as angle of elevation. Right. Similarly, you have another concept which is angle of depression. So this is nothing but, see, as I said you, let's consider this to be Mr. A again. So as I said you, there is some ball over here. So when he is having a ball, this was my original horizontal line. See, this was a diagram which I had taken. So this was something related to kite. So this angle whichever is formed is going to be angle of elevation. Right. Similarly, he is standing over here. This is the building. Suppose let's consider that he is standing on a building and over here there is a ball. So from here is just having a look at this ball. So whatever angle which is formed over here, that is this angle is said to be called as angle of depression. Right. That is what it means over here also. This is an horizontal line and let's consider he is going to stand on a tower or a building, anything. So there is some object over here. This is going to be a line of sight. So this angle which is going to get formed is going to be angle of depression. Right. What is the next thing? See over here, the angle of elevation of a point P as seen from point O. As seen from point O is always equal to angle of depression of O as seen from P. It is nothing but vice versa. Even if you stand from C over here, they're just trying to explain that this is going to be angle of depression and this angle is going to be angle of elevation. You stand from here, you see till here, it is going to form angle of elevation. You stand here and look at a point over here, it is going to form a point, form an angle of depression, right? The angles of elevation and depression are always acute angles which is less than 90 degrees, right? If the observer moves the perpendicular line, that is towards a tower or a building, then angle of elevation increases, and if the observer moves away from the perpendicular line, then the angle of elevation decreases. See, it is nothing but a person, Mr. M, is going to be here. If he's just walking towards or away, so how it is going to react is what they have said over here. If the height of the tower is doubled, the distance between the observer and the foot of the tower is also doubled. See, it is just as simple as that. If height of a tower is doubled, if the height is doubled, then the distance between the observer and the foot of the tower is also going to get doubled. See, if a person is standing over here and if the tower is going to get doubled, and if the observer and the foot also is going to get doubled, right? See, suppose if there is a question relating to the shadow, this shadow has to be equal. This is going to be a shadow. If till here was in the first case only till here was your shadow, but since this has doubled, even the shadow also is going to get doubled, right? So this can be a simple example which you can consider. If angle of elevation of sun above tower decreases, then the length of shadow of tower increases and vice versa. So even this can be related very easily. Next thing, angle of elevation. In the below figure, the line AC is drawn from the eye of the student to the top of the miner is called the line of sight. So over here they have just explained you what is going to be your line of sight. See, this is going to be a tower, so the person is going to just stand over here. From here, if you have to see the tip of it, it is going to be the line of sight, and the angle which is going to get formed is going to be your angle of elevation. The same thing they have just given you with an example, right? See, over here also, as I said you, the kite one only they have shown over here, so the person is standing over here. This is your horizontal line, right? When this is your ground level and horizontal level is going to be a different level. See, because see here also you can relate. This is your ground and this is parallel. Horizontal level, whatever the statement they have given, from this diagram you can understand that it is going to be parallel, right? So from here, if she's just going to look at the kite, then that line is going to be called as line of sight, and the angle whichever is formed is going to be angle of elevation. Next thing, same thing, angle of depression they have given you through an example over here. See, she's standing on a building, let's consider over here. So this is going to be a ground level, right? As I said you, there is a ball over here, and this is going to, whatever the line, whatever the side she is, till the end, whatever she can see, that is going to be a horizontal level. This consider it to be ground. If you can observe, ground is parallel to horizontal line. She is seeing till here, this is going to be a line of sight, but the angle whichever is going to form is going to be your angle of depression, right? Next thing, trigonometric ratios, T ratios of an acute angle of the triangle. So in a plane, see, this is nothing but the same thing which we have considered in right angle triangle, that is introduction to trigonometry. First consider a right triangle. So over here they have just said you, see, rather than this we can just consider a triangle which is right angle triangle. So ABC, if you consider B to be your angle which is equal to 90 degree, this is your hypotenuse square, and other two sides is what you'll be having. In the same diagram, if you just have to consider in x over y plane, let a revolving OP starting from OX trace out, XOP is going to be angle theta. So over here they have given you angle O to be equal to theta. From point P x comma y, draw PM which is perpendicular to OX. PM perpendicular to OX. This is your OX. So see what happens when you draw a perpendicular line. that is when it is going to form a right angle triangle. See, basically when you just draw this, only the replica of it is going to be the normal simple triangle. So over here this is going to form a 90 degrees. Then what does that mean? See, here you have a theta. In introduction to theory class only we have seen that whenever you have a theta, opposite divided by hypotenuse will be having a formula. Similarly, see, rather than that, see, opposite is going to have a number. Let's consider a variable to be y, and the adjacent, there will also be an adjacent which we consider it to be x, and you have r. Suppose if my theta would have been over here, then opposite would have been here and adjacent is y and hypotenuse is going to be equal to r. The same thing they would have explained it to you over here. So what is sine theta formula? A formula is going to be opposite side divided by hypotenuse. So over here, wherever, see here, as I said you, this is going to be your opposite side. So over here you have y divided by hypotenuse, which is going to be r. So y divided by r is what you will be getting. So cosec theta is nothing but reversal of it, that is just reciprocal. Opposite by hypotenuse is what you will be having for sine. For cosecant it is nothing but reversal of it. So for cos it is adjacent by hypotenuse, and for tan it is going to be sine divided by cos. Right, for tan it is that way. So once you consider these two, it is very simple for you. Cosecant is going to be reciprocal of this, and secant is going to be the reciprocal of cos theta, and cot theta is going to be the reciprocal of tan theta. The same thing, reciprocal relations they have given you over here. Right, for cosecant it is going to be reciprocal of sine, for secant it is reciprocal of cos, and for cot it is reciprocal of tan. Once you get this, the quotient relations, as I said you, for tan you can also write it using sine theta divided by cos theta. The same thing cot can be written as it is nothing but reciprocal, right? So it is going to be cos theta divided by sine theta. The next thing is going to be trigonometric ratios of complementary angles. Even this also we have used in our introduction to trigonometric chapters. So even in this chapter also we will be having few examples or questions relating to this. That is, sine can be written in basis of cos, tan in terms of cot, secant in terms of cosecant. Once you write that, the same thing in a reversal, that is, if you consider cos over here, you will be getting sine on your right hand side. So you just have to understand these three formulas. Sine 90 degree minus theta is going to be equal to cos theta. Tan 90 minus theta is going to be equal to cot theta. Secant 90 minus theta is going to be equal to cosecant theta. Right. Once you understand this, then it is nothing but your this formula basis chart. So over here also all that you have to understand is going to be just these two things. That is sine A and cos A. Once you understand this, tan A is nothing but just divide sine A divided by cos A. See, 0 divided by 1 is 0. 1 upon 2 divided by root 3 upon 2. 2 and 2 gets cancelled. 1 divided by root 3 is what you will be having. So this cosecant is nothing but reciprocal of sine, secant is reciprocal of cos, and cot is reciprocal of tan. Right, it is very simple. So all that you have to do is just understand this sine A and cos A. Right, with this we'll just start with few question answers now.